R is bounded by the lines x equals 1 and A, and y equals 0, where A is a constant greater than 1. Right, they start by telling us, that the area is 16. And so there's an immediate thing that we're going to have to integrate this to find out the area first. So we are told that the integral from 1 to A of 6 over 3x minus 2 dx equals 16. And that's going to allow us to find out the value of A.
Get like 48 points.
This is great. This is the reason this is in there. Is that so often students see an integral where it's an ax plus b at the bottom and immediately think that's going to be natural logs because it's over the function. But you only do natural log if the power is 1 on the bottom. If you're integrating something to the power of minus 1. This, we're going to think about this as being 6 lots of 3x minus 2 to the minus a half. And all that we're doing with that then is using the same rule that we first learned about integrating. It's nothing to do with natural logs. It's the rule that you may have written down somewhere that says if you integrate ax plus b to the n, you get 1 over a times n plus 1 ax plus b to the n plus 1. Let's see, that's the rule that we're working on, because that rule is true all the time except when n is minus 1. And n isn't minus 1 here, so this is the rule. Alright, does that make sense? And so often people get kind of drawn into a natural log thing with this. And so we'll integrate it and we're going to get, well, following this rule, we've got 6, we're going to be dividing that by 3, and minus a half plus 1 is plus a half, times 3x minus 2 to the power of a half, between 1 and a. And that's still equal to 16, because that's what the question said. What have we got there? 6 over 3 is 2, divided by half is 4. We've got 4 times the square root of 3x minus 2. Between 1 and a is 16. Now we're going to put our limits into that. We've got 4 times the square root of 3a minus 2. Take away 4 times, well hang on, that's the square root of 3 minus 2. Square root of 1. So it's just 4 then, isn't it? Equals 16. You alright? So we rearrange this now. We've got 4 times the square root of 3a minus 2 is 20.
6.
So the square root of 3a minus 2 is 5. If we square both sides, 3a minus 2 is 25, so 3a is 27. So a is 9. So that bit was aimed at getting the right value of a. Find the value of a and hence find the exact volume of the solid formed when it's rotated completely around the x-axis. So now we're into our volume of revolution thing. We're now saying that volume is the integral from 1 to 9 of pi y squared dx. And this was a clever question. I like this question because it really tested your knowledge of this integration bit. Because it got you to do both types. Because now, if we, that's 9 now, if we square y, we get 36 over 3x minus 2. And now this is the natural log type, isn't it? Because this is the type now that we say that if we've got 1 over ax plus b dx, we have 1 over a ln ax plus b plus c. That's the type, that's the thing we get when n is equal to minus 1. And so now we can do the integration. What we've got, 36. But we're dividing by a, so we've got 3 there. The natural log of the modulus of 3x minus 2, 1, and 9. We've got pi times, if we start putting some numbers into this, we've got 36 over 3, well that's 12, times ln 25.
Yeah.
Take away 12 ln 1. And ln 1 is 0. So we've got 12 pi ln 25 as our exact answer.
If you got A is 6.
Okay.
Yeah, I didn't actually get A.
If you had 24 pi ln 5, so that's just as good, isn't it?
Last time.
Because you can write that as being pi squared.
Yeah, was that what I was doing?
24 pi ln 5 is just as correct. Are we happy?
Yeah, then I just said.
Great. Problems?